So this is a phase diagram. You can have a phase diagram for any really material. Sometimes they'll tell you the identity, sometimes they won't. In this case, they're not even telling us what it is. But what you need to pay attention to is with a phase diagram, it's always pressure on the y-axis, temperature on the x. So it's always pressure versus temperature. Pay attention to the units that they give you. Pressure is in atmospheres here, temperature is in Celsius. The other thing you need to know is what these wedges stand for, what phase of matter they're representing. So the one always to the left top of the graph is going to be the solid. The middle little pi wedge is going to be the liquid. And the bottom right is going to be the gas. The size of these wedges may change depending on what the substance is, but it's always going to be the upper left is solid, the middle is liquid, and the lower right is going to be the gas. In this first question, it asks you for the normal freezing point, and you're going to remember that the word or the term normal always stands for 1 atm. So this is talking about the freezing point. It is talking about the point where a substance freezes or goes from the liquid state to the solid state. So the place where that happens is right along this line right here. This is where it is freezing. Once it crosses over this line, it goes from the liquid state to the solid state. The temperature that this happens changes because of the pressure. So that's why you see a bunch of different temperature values. So to get the normal freezing point, you're going to go to where you see 1 atm, because remember that's normal. I'm going to follow that line until I hit my transition point, the transition line from liquid to solid. And I'm going to trace that down, and I'm going to see that the temperature that this happens is 100 degrees Celsius. So that is the freezing point on this line. The next question says, what is the normal melting point? So again, it says normal, 1 atm. I'm going to think that melting is when you go from solid to liquid. So this time I'm transitioning this way over the line. But if you pay attention, at 1 atm, the melting point is the exact same as the freezing point, and that will be always true. The freezing and melting point is actually the same for every substance. So go to the next one. What is the phase of the substance at 2 atm and 100 degrees Celsius? It's asking for what phase is it in, solid, liquid, or gas. It's giving you 2 points, and you sort of just plot the point. So it's the phase at 2 atm, so I go up to 2 and 100 degrees. So I'm just going to plot over. 2 atm and 100 degrees is going to give me this point right there. And the value of that point, or the phase that that point is in, is a solid. So you're just really just going to plot the point and figure out which wedge it's located in. Same for the next one. What is the phase of the substance at 1.5 atm and 50 degrees? Now the only trouble here is 50 isn't marked. I have 100, I have 0 and I have 100, so 50 is going to be about the in-between, so about here. And I'm going to trace that up till I hit 1.5. The dot there would be about there. So then again, you're going to see that this is in the solid state. So that's another type of question you can be asked. This next one talks about the triple point. Remember, the triple point is the part on the graph where all 3 phases meet, where the substance can be in any of the 3 phases. It's not in all the 3 phases at the same time. It just has potential of being in the 3 phases, and it's right here. It's always going to be a dot. And what this is asking for is the conditions. It means at what pressure and what temperature does this exist. So this is right in the middle of a lot of things. So you're going to have to do some estimating here. So we're going to do, it's a little bit above, halfway between 0.5 and 0.75, and very close to the 100 degrees. So we can say it's about 80 degrees and 0.6 atm. There's going to have to be some leeway with those, just because of the nature of the question. So you're going to have a little bit of wiggle room there. So if the quantity of this substance has at an initial pressure of 1.25 atm and a temperature of 300 degrees Celsius and then lowered. So now we're doing a new thing. It's actually going to change, which means the phase is going to change. What phase transition would occur? So what you're going to do is plot the first point to figure out what phase of matter it starts in. So it's at 1.25 atm right here and 300 degrees. So I'm just going to trace over 1.25 and 300, this point right here. Then it says the pressure is lowered to 0.25. So the temperature doesn't change. So I'm still on the 300 line. I'm just going to go down to the 0.25. And I'm going to see if I started here in the liquid, it went here to the gas, the transition that would occur is called vaporization. Now just a little hint, if you weren't quite sure what the phase change was, just at least tell me that you know that it's a liquid to gas transition, maybe if you don't remember the name. And finally, if a quantity of this substance was at an initial pressure of 1.25 atm and 0 degrees, so now here's my 0 line, 1.25, I'm starting right here at this dot, and then lowered to 0.25. So again, my temperature doesn't change. I'm just going down to 0.25, what phase transition would occur. So I started here in the solid, and I ended here in the gas. So this time I went from solid directly to gas. So that is called sublimation. Remember, sublimation and deposition is where you skip the liquid phase.